Hey, happy Sunday. This is PFG Live, brought to you by Kinetic Precision. Who knows that if you're not flat, you are not where it's at. Welcome aboard, everyone. Let's see. We got Evils is in the chat from Ghent, Belgium, reporting something around 20 degrees C. Josh is with us from Snow, Mexico, southern Manitoba, in which he is reporting, let's see, winds are 11, gusting 18, minus 23 C. Minus 23 C. Thank you. Welcome aboard. DBX near the White Plains of New York is 090 at 8 knots. 060 variable 120 with 1.5 mile visibility in rain and mist, overcast at 300. Sounds lovely. Warren Jones from Sutton, New Hampshire reports 22 degrees Fahrenheit, light sleet, and winters. Josh, our audio check, says check, check. Dale in the, believe it or not, Puerto Vallarta, Mexico, says it's 26 degrees as opposed to minus 26 degrees when he left home. In Edmonton, Alberta. Paul Morley is with us in Dallas at 39 degrees Fahrenheit, 4 degrees Celsius, clear skies, and cold weather. Josh says wind chill is only minus 35 C. Not bad. Chris O is with us at 66 degrees Fahrenheit, partly cloudy in Los Angeles, California. Welcome, Chris. Bill Olney in Rome, New York, 32 degrees, right on the hairy edge of freezing. Winds are 20 to 30 miles an hour with lots of sleet. Yowza. Arstead, also known as David, says 24 degrees Fahrenheit and windy in central Illinois. New York Machinist says freezing rain and slush all over the southern tier of New York. Welcome aboard, sir. Carl Tauber is in the Rhode Island reporting 32 degrees and freezing rain. CJ Stevens is with us at 35 degrees and windy in East Tennessee. And let's see. Test room from Oostkappelle, Netherlands. Welcome aboard, sir. He says 1.5 C and 85% relative humidity and a little slow early this morning. And this just in from Puerto Vallarta is Dale. Dale, can you give us a weather report? You could turn your audio on. You're choppy. You're a little choppy, sir.
It's beautiful. It's sunny. It's Mexican internet. You get what you get.
And you don't get upset. Thank you, Dale.
But there's the view.
That's awesome.
You're welcome.
Thank you so much. So that was from live from Puerto Vallarta, Mexico. Art That Makes Art says it's snow in south central Idaho. I'm shocked and stunned. And right now in Windham, New Hampshire, we're reporting 36 degrees Fahrenheit, 89% relative humidity, and the winds are out of the west-southwest at 14 miles an hour. Let's see. Manchester Airport is reporting winds are 360 at 9 knots, 1.5 mile visibility, light snow, vertical visibility of 1,000 feet, temperature -2, dew point -4, altimeter a 2.9er, a 3.9er. Remarks are depressing. So welcome aboard. It is, we have 6 inches of snow on the ground. We have freezing rain coming in, pestilence, and it's basically pretty wintry here. So I'm staying in. I'm hiding. My beautiful bride is, I'm looking at the cameras over here, is brushing the snow off of our vehicles as we speak. Hello and good morning. So it's been a great week, and I'll give you the PFG Stones report from PFG.Stones.com. We received a big order with 2 different sizes in relatively high quantities for me, and I was determined to get it done this week and get it out the door, which I did. And almost as I'm driving home from the post office, this order pops in for yet another size, which I had 0 inventory, which was the 6 inchers. Those got done this morning. Where their 6-inch stones are back in stock, 4-inch stones are back in stock, and minis are back in stock. So I am like happy and tired. This week I was busy getting a soldering project done for a big project that I'm working on for a client. And I realized, gee, that would be a great topic. So I said, well, we'll do some talking about soldering this Sunday. So I said, well, I probably have a couple of different types of solder. And I started looking around at the ridiculous numbers of solders that I have available in the shop. And I said, oh yeah, we have to discuss this. So that's how we ended up with the definition of today's topic of soldering, which will be actually quite interesting. So we will get into that. I will thank Evils. We were talking while I was working on stones the other day. He's taken a course in machining and talking about learning this new CNC machine. And I was kind of giving my opinion, which was asked for, I'm just saying, and about, how to go about it so that you minimize the chances of crashing. And then I realized that's a good topic. So the picture in the thumbnail also contains a little bit of humor with my crash start and crash hold buttons. That was compliments of Dale, who you just heard from Puerto Vallarta. Thank you, Dale. And those are now famous. They're famous now. What can I say? So that's what's cooking. I'll remind you guys that if you're in the chat, either on YouTube or in Discord, you're welcome to pop in a comment, a question, or a snarky remark. Wasn't last week pretty awesome with Tom and Robin? That was an amazing event, and I think if you went back and you watched that, I think the thing that was really stunning to me, if you got your brain in the right place, was not watching the details of what they were talking about, although there were some really cool details, but watching how they approached problem solving. Here you have two guys that are really, first of all, they're friends. They're very comfortable talking to each other about stuff, but they're at the top of their game, and they're going back and forth and tuning in some ideas, and it was really cool to watch. So if you didn't live through that last Sunday, we saved it for you on YouTube from last week. It's called Two Guys and a Pencil, the problem process number 1. So we're putting together the problem process number 2. If you have a problem that you would like to submit as an idea, go to pfg.gg/links. Scroll down a little bit. You'll see the banner. Hit the big red button, and it'll bring up a Google sheet, and you'll be able to just fill out the Google sheet and submit your idea. Josh, very nice of you. Josh says it's one of the best episodes yet. Thank you very much, sir. And we'll go from there. I don't know when it's going to be. Maybe we do this once a month, once every month and a half, 2 months. Not sure. We'll see how it plays. New York Machinist says, we want the anti-sleet machine. Solve freezing rain for us all. Wouldn't it be nice? Oh, thanks, Josh. Josh put up the actual Google Docs link into chat. It's the same link he's pulling it right off of our links page at pfg.gg/links. Thank you, Josh. But that's how you submit it. So if you watched last week and you said, oh, I wish they would talk about, nuclear screwdrivers, you can go to submit your question, your idea about nuclear screwdrivers, and we'll try to get to it. And if you guys have any questions about any of that stuff today, before we get into our other topics, I'd be happy to address that. So yeah, everybody's checked in. I'm just looking for additional weather stuff, and I'm waiting for the apocalypse. So I'm planning to my CNC operations, and I'm trying to be efficient, right? So you always want to have the CNC machine doing its run cycle while you're able to do something else. And while I'm doing that, I realized that I'm running up and down stairs because I've got the laser downstairs, and I'm out of stickers, so I have to run upstairs and I have to get stickers. And one of the things that helps is having the spreadsheet and just working for the spreadsheet all the time. So that we keep it pretty efficient around here. Anyway, so I digress. Let's talk a little bit about the minor topic today, which I consider the planning for not crashing. I've heard, I watch a lot of YouTube channels from folks we like, A-Bomb79, and I watch Keith Rucker over on vintagemachinery.org, and I watch just a bunch of the machinists. I'll if I try to name them all, I will no doubt forget them. But everybody has a take on this, which is, how do you go from writing your CNC code and getting it over to the machine and getting it started. The Air Care Cave Shop is with us. He says, "Hi all, how to catch the start of the 500? Is the Indy 500 today? Is that what I'm missing? You could tell that I am completely uneducated. So fill us in on this. Is today the Indy 500? Or is this something else?" He's typing. Daytona. The Daytona 500. Thank you. All right, so Daytona is on today. So if you will not be insulting us if you have another screen on watching the Daytona 500. So I want to talk a little bit about my method for going from, generating machine code to running the machine and not crashing. Or a positive way of saying that, of having a smooth execution of your CNC code. And it's pretty important because, boy howdy, if you have all the knobs turned up and you hit that green button and that machine wants to go somewhere, it's going to go there faster than you have the response time to stop it. And that could cost you a lot of money. So it all starts with, your CNC code generation. In my case, it's Fusion 360. It used to be SolidWorks, but that was way too expensive. So years ago, I switched to Fusion 360. When you're generating your CNC code, you have some things you can do. You could put optional stops in wherever you want. Typically, the post will put in optional stops at tool changes. So if you have optional stops on for your machine, when there's a tool change, it'll stop, and then you have to take some manual intervention to get it going again. If it doesn't do that automatically, you can choose to put in optional stops at logical places. And then once you get through the process of wringing out your code and your whole process, you could turn off optional stops and everything will move right along. So that's something you can do again during the creation of your code. Another good thing to do during the creation of your code is if there's any information that the operator, which could be you, needs at the console, this is the place to put your comments in. So figure out how to put comments in your code so you can glance up at your control and you can see these comments going by, and that will also potentially help you smoothly get this thing rolling. So one of the things that I really like about Fusion 360 I'm sorry, that was politically incorrect. It's now called Autodesk Fusion. We don't say 360. So Autodesk Fusion, the post is written in a JavaScript-like language. It's pretty straightforward. It's pretty easy to learn. One of the things that I have done is I've taken the post that others have written for similar machines. I've modified it for my machine in a couple of important ways that don't have anything to do with crashing, so I don't want to dwell on that. But one of the things I did is I clarified the post. Believe it or not, I commented the post. I made it a little more understandable to read by changing how it's formatted. It makes it a lot easier later to go in and see what you meant. And you could argue that having a very clear post and being able to make post modifications clearly and sanely will also prevent crashing. But I put in things like delays for when the coolant turns on, put in a delay. How long should the delay be? That's all controllable. But every tool change does have an optional stop, and I think that's a useful thing. You can also put them in manually. So you generate your code and you think you're ready. So you go to your machine and you load up your code. Now on the front panel of the machine, there's going to be a couple of controls normally. Now I've run my Fanuc control on the Sharp vertical machining center. I've run the Haas control on the TL1, and I've run the Fanuc control on the grinder, and all of them have a place where you can control the feed rate and turn it down as a percentage of what was programmed. And it's very important to understand how on your machine that control behaves. On the Sharp, which by the way, if you're playing at home, it's a Sharp SV2412S. Okay. Details to follow. But the feed rate control is very interesting in that it's a clicky control and it goes from 0 to 200%. So 100%, the normal setting is at 12 o'clock. And when you're proving out a program, as we're going to talk about in more detail, and you turn it way down, if you go all the way down to 0, it literally stops. So one of the most important places to keep your right hand is on that control, because you can be, watching it move slowly, and then if you go down to 0, it'll stop it. So that's a really useful tool. Art that makes art. Wes says, I think most crashes are caused by the wrong tool offsets or the wrong work offsets. Next would be speeds and feeds. Excellent point. So you've arrived at the machine with your code, right? And you have a memory stick, or you have some way of getting it into the machine. And let's address what Wes says. You touch off your tools. There are a bunch of ways to set your tool offsets, and I'm just going to tell you what my way is, and the rest is up to you. What I do is I use a standard length as my 0. So I have for Mari Tool, I bought a standard. It has a standard gauge length of 4 inches. I think it's 4.00 inches on the gauge length. Plus it has a diameter of a very specific amount. Hey, welcome aboard. Let's see. My K.O. Kalishnikov, welcome aboard, sir, in Strasburg, Ohio. 4 inches of snow since 9 a.m. and 33 Fahrenheit. Welcome aboard, Adam. You could run, but you can't hide. So, we got 6 inches. Go figure. So I touch off, I put one of those Z measuring devices on the table. I go down, I touch off the length of that, and now I have a reference. the other thing I do is I have a 3D taster from, oh, I'm forgetting the name of the company. What's the name of the company that makes the 3D taster that we love? Somebody will come up with it. Hamer. Thank you. Hamer. I have a Hamer taster. My Hamer has, I know the gauge length of it. It's on a sticker on the side, but my Hamer, when it says 0, it's 0. So that's my 0, is my Hamer. So I'll go down and I'll touch my Z measuring device and I'll get what it thinks is 0 on the Hamer, and I'll hit the button and reset that to 0, and that's my 0. And then I will proceed to touch my tools off on that Z measuring device. No, I do not have a probe. I'm sorry. I'm in the poorhouse. I can't afford a probe. So I get all those set, and as Wes points out. So that's an important part of the process, is to touch off all your tools. One of the tricks I use is I have a little rack that I 3D printed, and that rack holds tool tags. So on a Cat 40 tool holder, you can make or purchase a plastic tag. I'm probably, nobody's going to be surprised by this, a plastic tool tag that slides into the groove around a Cat 40 tool holder, and you can have what is the tool number and what is the gauge length and all that kind of stuff. And when it goes into the machine, you pull the tag off, you put it into the pot, and that goes into my little rack. So at any moment, I know if the tool is A, touched off. Wes says, probes are a game changer, boomer. Thank you. Thank you so much. Maybe one day I'll be able to afford it. Greenwood AG says, hands on the speed and watch the distance to go as the tool approaches the work. Excellent. We're getting there. We haven't even loaded our tools yet. So Dale says, I don't like the term crash. I say I was trying to do stir friction welding, and we're still in the prototype phase. Nicely done. New York Machinist says, having a Hamer and a Renishaw OMP60, the 3D taster is 80% as fast and just as good with slightly extra functionality. But I do like a probe for cool factor and 3D inspection. Having two ways to do it is also excellent. Nice job. So having the little rack makes sure it's a technique to make sure that you have touched off every tool. One of the errors is forgetting to touch off a tool and having some random number in the control for that tool, and that's a bad day right there. So getting the tools touched off correctly for mills. Sometimes the diameter of the mill is very important because you're using compensation in the G code. You have to get those entered also. So every machine is different. I'm not going to dwell on that. But getting the tools touched off is important. So once that's done, and you've also touched off your work holding, so now your work holding, you know where that is, you're ready to go. Or Josh says, or putting the tool in the wrong pot or the wrong spot. Not that anyone has done that. No. Okay, so you're ready to go. So the first thing you're going to do is here's what I do. Okay, my process is we have a global offset in the Fanuc control. So even though you may be working at G54, or whatever, there's a global offset, and you could take the whole world and move it up in Z. So I move everything up an amount such that it'll clear the work. So usually for me, it's like 3 inches or 4 inches. I just move the whole world up, and you'll see why in a second. Hey, welcome aboard, Ugly Skull. So Adam says, probes are great for idiot checking things like stock being loaded correctly or if you have an operation where you remove clampos midway, you can verify that the clamps have been removed. I can go months without probing a work offset. Outstanding. Yeah, some of the, if your machine is set up, like I know you use a, what's the brand of the work holding that you use? Aroa. You use an Aroa pallet, right? So once you get that thing touched off, it's really nice and it's really repeatable, and you could change between things without checking it. My work, I tend to be not keeping the same references, so I usually have to probe in the references for the work holding also. So that's part of my checklist. So you've set the work offset, you've set all your tool offsets, you've got your program in the machine. My process is I set the global offset up. So Z3, for example. I set the feed rate all the way down to 1 click above 0. So it's, I think that's 10% on my machine. And then there's another knob for the rapids. Now, if I turn my rapids all the way down, there's 4 settings. I think it's 50 millimeters a minute. It's very slow. Then it goes 25%, 50%, 100%. So usually, if I'm feeling like everything is smooth, I'll leave it at 25% rapids. That's a reasonable slowdown. If I'm really nervous, I'll put it at that ridiculously slow rate. And then we run the program. Oh, we turn optional stops on, and then we run the program. So you're going to be cutting air, and it's going to be slow, and it's going to feel like you're wasting time. And this is the conundrum of CNC machining, is that you've got to cut air, and you've got to make sure that everything's working before you let the machine loose. But if you do that, you could have a lot of confidence and not worry about it. It's a great thing to do is when you got all your confidence because you've just dry cut everything. Now you can go 100%, 100%, hit the green button, and off it goes, and it does its job. So you start running the program, you cut air, you watch all your clearances, you get to your optional stops, you let it go from the optional stops, and you go all the way to the end of the program. Don't cheat. Don't get halfway through the program and say, "Oh yeah, everything's fine," because that's where Murphy is waiting for you right around the corner. The other thing that I find happens is I'll do that and I'll find an error. I'll find it like, "Oh, look, why is it going over there?" And of course, my hand's on the knob, so we turn it off and we go to fix something, and now you could start again. Well, you could speed up through your program cutting air up to that point, and then again slow down and check it out. Eventually, you prove out your entire program. Life is good, and now you're ready to cut parts. You may even have already loaded a part in your work holding. Now you could take your global offset from Z3 or Z4 inches and set it back to Z0. Again, cutting the first part, hands on the control, slow rapids, let it do its thing. One warning, however, there are cases where cutting with too slow a feed rate is bad for the tool. Okay, if you're cutting aluminum with anything, it's like bubble gum. Don't worry about it. But if you're working with hard materials and you start rubbing, you could end up eating up a tool too quickly. So use caution on the feed rate. At this point, you might have enough confidence to let it rip. And then again, your hands are on the controls, you're slowed down, you get through part number 1. If part number 1 works, you're cleared for takeoff. Set feeds to 100, set rapids to 100, and start making parts. The last part I did, I showed, was a little brass part that was for this RF project that I'm doing. And it didn't look like much, but it had to be right, and I needed the right number of parts. So same exact process I just described. And then it was, I forget what the process was. It was 1 minute per part or something. It was lovely. So you kind of walk into it, and it feels way slower than manual machining for a reason. And then after everything checks out, it's way faster than manual machining for a reason. But don't not do those slow, checkouts and air cutting, and you have to go through that process. Sometimes it sucks and it's boring, but that's how you not crash. Evils, did I hit all the high points of the conversation we had the other day? Because I think that's basically what we were talking about. All right, go forth and make some CNC parts. I think you're ready to rock and roll. Evil says, cut the errors by cutting air. Nicely done. Well done, sir. Can we get a sticker for that, please? The graphics department, cut the errors by cutting air. You working on that? Okay. All right. Good topic. Are there anybody have any questions or comments? Like, did I say anything that yeah, Josh says that also works in space. But in space, nobody can hear you scream. Yeah. It's the people that make errors. The machines just do what you tell them to do. So, okay. Soldering. So I've got these parts to solder, and I do what I always do. I talk to my people who have more experience than me. I learned how to solder at the age of, I don't know, I'm going to say 10 years old. It might have been plus or minus. But doing electronic soldering, my dad taught me how to solder, and I learned how to solder parts together. And this is a resistor, and that's a light bulb, and this is a wire. Greenwood asks, do you use the simulation in Fusion? Yes, I use simulation in Fusion. But I think the question behind your question is, did that ever prevent a crash? I don't know. I don't think so. I think things look really good in simulation. So I don't think it obviates what we're talking about, but I think it's a good idea. Josh says, did you heat the iron in the coal forge? Yes. Well, we couldn't afford coal when I was growing up. So basically, no, I remember in fact, the soldering iron that I had growing up, this is no joke. The soldering iron that Dad put in front of me and I learned is sitting in my lab right now. It's a Weller. It's a very old Weller that we bought. I think I might have learned on the Hexagon, which I also have in the basement. So yeah. No, we had electricity. My sister would brush her hair really quick, and we would collect all that electricity and use that for soldering. That's how we got the electricity. We were poor. So anyway, learning how to solder early was my thing. So it sort of was like, oh, okay, yeah. And you use this solder, it comes on a roll. And, if I look over to my right here, it's like, yeah, there's a roll of solder, and you that's the stuff. And it's sitting there next to the soldering iron, so it has to be the right solder. And then, of course, I go down my path in the world of electronics, and I start learning a lot more about soldering and different types of solders and that kind of thing. And then we get to circuit boards, and soldering on a circuit board was a thing. I'll tell you a funny story about my first job in the industry. Was when I took a term off from school and I went to work for a company called Bulova Systems and Instruments. They were out on Long Island in Valley Stream, New York. And was that on Long Island? Or was up? Anyway, Valley Stream. DBX, you know where that is. So I would get on the train. I would take the subway to the LIRR, get on the LIRR, go out to Valley Stream, and go to Bulova, go to work, punch my card, and that's a whole other story. But one day we had a project where we blew up a machine that we were building. What a shocker! The technician I was working with wired the AC to the 5-volt bus, and stuff blew up quite nicely. One of the things that happened was we destroyed a Hewlett-Packard frequency counter, and I took it upon myself to repair it. So now, back in the day, HP had magnificent manuals, including repair. And, I referred to the manual, and I found the parts that had exploded, some ICs and stuff. And I desoldered, the ICs, and HP made recommendations. But then I had to rebuild the board using fine wire to replace traces on the PC board, which had vaporized. So, I did all this stuff. And to me, it was, another Tuesday. Soldering, doing that kind of soldering work was pretty normal to me. Well, the two engineers that I was working with, one of them in particular, was like over the moon about this repair. And he was like, "Oh, come here. You got to see this guy doing this thing." And it was kind of interesting. Like, oh, golly, my skill in soldering was so interesting to these guys. I didn't know that I was that advanced. So electronic soldering. Oh, by the way, rest of the story in that particular company, the guy I worked, the boss of the department that I worked for, was just, it came time. NASA was going to run they were going to run a NASA soldering course, which is what you do sometimes in these companies, and he wouldn't let me take the soldering course. I was really unhappy with this guy. So, it was only later that I learned that there's different solders and there's different rosins, and we're going to talk about that right now. First of all, what is soldering? Soldering is joining two parts with a third alloy of some flavor that melts at a lower temperature than the parts that you're soldering. And you'll notice that definition also applies to brazing. So you've heard, you know what welding is. Welding is taking two parts and literally melting them together, and possibly with a filler material, which is generally approximately the same alloy. And when all the dust settles, they all are now one part, right? The same alloy. Well, brazing, as you are no doubt aware, is different in that you are not melting the parts that you're joining, and soldering, you're not melting the parts that you're joining. So the question is, what's the difference between soldering and brazing? Anybody want to take a shot at the difference between soldering and brazing? Because I looked it up today. Per the American Welding Society, Evil says one is mechanical. I would say no, that's incorrect. Joshua says temperature ? I would say yes. Temperature is, well, I'm going to give you half credit here, because temperature is the only definition between soldering and brazing, even though the word braze has, brass in the name, and maybe there's something. No, the definition is the temperatures at which it occurs. Robin's here. Hi, Robin. Welcome aboard. So the answer is 450 degrees centigrade. If it's a process that's lower than that, it's called soldering. If it's a process above that, it's called brazing. That's it. So soldering and brazing are really similar. Soldering is the lower temperature version of it. So 700 degrees Fahrenheit. I apologize. I'm going to be bouncing between Fahrenheit and Celsius. But 700 degrees Fahrenheit is what all of my soldering iron tips were when I got the fancy iron that took the temperature control tips. So that's the vicinity that we're operating in. And for the most part, any lead-based solder or similar, we'll get to that in a second, is going to be in that vicinity. So Evil says, so if I crank my iron above that, I'm brazing, no matter how much my electronics solder wire hates it. Yeah, pretty much. I guess you could make the argument that you have to have the appropriate, brazing wire, but it's really just all terminology at that point. But it's not welding. In fact, when I was learning how to weld, and I took a great course with Roy Crumrine of Crummy Welding, who, by the way, made me this shirt. What a coincidence. Roy made me this shirt. One of the things we did was TIG brazing. I found TIG brazing very hard to do because you're dealing with a TIG torch that is 10,000 degrees Fahrenheit, and you're trying to not exceed the melting point of the base metal. It's a very, it's not easy. It's a very finessey kind of thing to do. So Carl says, so silver soldering should be called silver brazing? Yes. In my opinion, absolutely correct. Now, I'm not going to hold anybody, I'm not going to take anybody to task on calling one thing brazing and another thing soldering and blah, blah, blah. It's easier than calling it not welding. So, thank you very much, P1 on the sticker. Excellent. So let me show you some examples of soldering stuff that we have here. First of all, I've shown the soldering kit that I bought from Radnor, which is really Harris. This is the stuff that Robin likes, the Stay Bright silver solder and Stay Clean. So this is a silver solder. So let's talk about the difference between silver solder and an electronic solder. Here's the basic electronic solder that I grew up with. This happens to be an alpha metal solder. Okay, that's a per the label that I put on the front. It's a 63% tin, 37% lead. We're going to talk about that in a second. There are many, many other examples of tin lead solders. In fact, here's a picture. Let me get this picture up of the solders that I found in my in the shop. We have a 60-40 solder represented there. We have a 50-50 solder represented there. We have lead-free solders represented there, which don't have any lead in them. Let's talk about some of these. The most basic one is a 60-40 tin lead solder, right? And it has 60% lead and the remainder 40% tin. And if you read the data sheets, it has a little bit of antimony in it. Now, interestingly, this has 60-40 tin lead, and this has some weird number, 63-37 tin lead. It's like, what's the difference? And we're gonna explain that in 1 second. Here's another solder. This is the Odie solder that's in that picture there. I pulled its data sheet, and this is a they don't give you the proportions, but this one has tin, copper, bismuth, and silver. And because they have silver in there, they're allowed to call it silver bearing, okay, or silver lead-free. But in these, the silver is actually pretty low percentage-wise. Here's another solder. This is Alpha Fry. This is also, I think, in the picture there. This is 95% tin, 5% antimony. Okay? Lead-free. So the lead-free solders are very popular with plumbing because we don't want humans ingesting any lead bits, and that makes sense. Whereas in electronics, we started with lead all over the place. Well, in recent years, all the electronics wants to be lead free. So they had to develop a whole batch of new solders in the last 20 years. Indiana John, welcome aboard. He says, is just turning 21 degrees Fahrenheit in Bloomington, Illinois. Welcome aboard, sir. And then I came, yeah, Robin, I am so with you. Robin says, lead-free sucks. I will point out that you did not split any hairs on that. You were pretty straightforward. So here's one of those rolls on the far right of that picture says 50-50. And in fact, I found a data sheet, 50% tin, 50% lead, and it's for doing stained glass work, where they put like a foil around the stained glass and they solder those together, and that's how you make these wonderful stained glass windows. Well, it's 50-50. Now, those aren't fancy numbers. It's half tin, half lead. Have a nice day. So I'm going to guess that this is based on an ancient formula, because there's a reason for it not to be 50-50. But in this case, they say satisfactory corrosion resistance, and generally used where temperatures are critical because it has a pretty low melting point. But I will argue with that in a second. Let's see. Then we move into some of the so-called silver-bearing solders. Here's the one we just showed you, the Stay Clean solder. Let's see. Where's the Stay Clean? Oh, before I get to Stay Clean, this is from Alpha Solder. This is the company I just showed you. They have a whole data sheet of a bunch of their different solders. Listen to these. Where is it? Yeah, this is the 6337. This is the exact one I just showed you. It had a solidus, that means where it solidifies, temperature of a single number. There's a hint here, 183 degrees C, and a liquidus of 183 degrees C. And it goes on to give some other specifications, and that's 63% tin, 37% lead, with a little teeny pinch of some other stuff. Hey, Tucker's here. 47 degrees Fahrenheit and sunny in Dallas, Texas. Sorry for being late. Hey, dude, welcome aboard. I assume you're in Dallas, Texas because of airline things. Because you're really close to Paul Morley. So you guys might want to get together. I'm gonna push aside some of the brazing stuff for later. Here's a bunch of this is the sheet that I was looking for. This is from Kester. Kester makes solders, and they have 6 different solders listed. So I'm going to read them out of order. They have a 95% lead, 5% tin solder. Why would you want that? Well, the lowest temperature listed here is 300 degrees Fahrenheit. Nice low temperature. That might be important. Yes. So CJ Stevens, your Lincoln brand silver solder is made by Harris. Lincoln bought Harris. And Radnor is a Lincoln brand. Do you see what's going on here? It's all made by Harris. They have another solder, 5% tin, 93.5% lead, 1.5% silver, lowers the melting point to 296. So you can see some of these formulations are specifically to get the melting point where they want it. But there's a little secret coming. 60-40, good old 60-40. 183 degrees C is the lowest melting point. 50-50, 183 degrees C. 60-40, it's just a different solder. But all of these have a range of temperatures. For example, 60/40, that's 60% tin, 40% lead, it says melting point 183 to 190. Well, wait a minute. Give me a number. No, sorry, it's 183 to 190. Whereas 6337, which by the way is the one I showed you here, okay, very standard in electronics, has one number, 183C. Does anybody know why all of these solders have a range of melting temperatures, but 6337 has a single number? Does anybody know the answer to that? Anybody at all? Thank you very much. Evils. Okay. Somebody get that man a cold iced tea. Evil says, yep, Carl knows it. All the people on the podcast are quietly waiting to hear what the excitement is. So Evil says the eutectoid point. Carl says it's a eutectic. And the best thing I heard is Evil said no slush. Okay, so what does this mean? So tin and lead, let's say we have a tin lead solder. Keep it simple. Tin and lead, right? Tin has a certain melting point. Lead has a certain melting point, and they're different. And it turns out that if you have a mixture like 50/50, okay, which we saw in the picture here. If you have a 50/50 solder and you heat it up and it's all liquid and you watch it cool, okay, at some point one of them is going to cool off and solidify, the other one's going to stay liquid, and Evil's called it slush. That's a great term because it looks just like slush, and eventually it all solidifies. So 6337 solder sounds like it's a very precise number because it is. It's called a eutectic alloy. It's the right mix so that everything solidifies at one temperature. And that's really important for the performance of the solder, both mechanically and electrically. So let's take a look at what we call a eutectic mixture diagram. Okay? So up on your screen, sorry for the guys that are on the podcast, we'll explain it to you, is what we call a eutectic mixture diagram. So the temperature is in the y-axis, and the composition between the two main components, A and B, is on the x-axis. And in this particular drawing, in the center is a 50/50, is a particular mix, an AB mix, okay? So at the magic eutectic ratio, the A component and the B component go from liquidus to solidus. In other words, they turn into a solid at the same temperature. And it just goes bang from liquid to solid as the temperature drops. But now, if you move over, like instead of 6337, you go to 6040, which is only a little bit of a change, or worse yet, you go to 50/50, as you cool off, one component turns into a solid, and the other component stays a liquid until it goes below another critical temperature, which is labeled here as the eutectic temperature. So if you have the right composition called the eutectic composition, there is a eutectic point, and that's what's magic about 6337. So if you've never heard the word eutectic before, you've now not only heard it several times, you've heard somebody being very excited about it. So that's a eutectic. And that's why you'll see these magnificent solders, okay, of 6337. Along comes the hate for lead, okay? Man, you're fast there, buddy. Who did that? Evil started printing labels already. Nice job. Dale says, so there must be an advantage to a wider temperature range. So if you're designing a solder for a particular application, you might not care that it's not a eutectic mix. Okay. In fact, we saw in some of our examples, like a 95% lead, 5% tin. Okay. The melting point. Oh, I'm sorry. That's not the one I was looking for. But the melting point, the absolute melting point, may be in a more advantageous place. So you don't care about a eutectic, but a eutectic mix is much better for a lot of applications. But now you come along and you say, "Oh, I don't want lead." Like, oh, come on. So we throw out all of that technology and we start marching toward a lead-free technology. So I want to show you. Here's a really cool bar, okay? And this bar right here is a bar of solder. And ironically, here is the exact same solder. This wire solder is 32 thousandths 032 in diameter, and of course this bar is a serious bar. This is about an inch on the face, and it's triangular. This is a very common electronics solder now in wave soldering machines. So you guys have circuit boards, your computer motherboard is a good example, and it went through a wave soldering machine where literally there's a molten wave of solder and it rolls over the wave and everything gets soldered at once. So although there are other techniques also for soldering motherboards. So this is called SN100C, and it is a lead-free solder. Let's see if I have the SN100C composition handy. I do not, so we'll just skip over that. But this is a predominantly tin-based solder, and I have started using this for a very special application. So let me just jump into the other part of, here's another lead-free solder. Oh, no, this is a with lead solder. This is a solder paste. Okay. This is 6337, our favorite eutectic mix, but it's in a paste. What's the other component? SN100, I honestly can't swear that it's 100% tin. I don't think it is. But, oh, well, you would guess from the name, right? It might be 100% tin. It might have a little herbs and spices. I'm not 100% sure. But we're going somewhere with this. The SN100C, yes, many whiskers, handle it. But there was something magical about this particular alloy, and I'll show you what. Pictured on the screen is a little solder pot that I put together for running this particular solder. So there's a picture of this bar that I just showed you of solder, and there's a picture of a little bottle of flux. Now, flux is a very important part of the soldering process. Flux is what cleans the metals, essentially removing oxides, and gets them ready to have the solder march in and bond to them. So flux is built into some solders. Like, for example, the solder that I showed you for electronic soldering is called a flux core solder. It's literally a tube of the solder material, and the flux is in the middle. And that's just the standard stuff for doing electronics work. It's a flux core solder. I've seen, especially in plumbing, you can get flux core solder, and they'll say specifically it's an acid flux or a rosin core flux, which means essentially a base flux. And the flux is part of the process. But some solders, like this big bar I just showed you, do not have a flux associated with them. You have to add the flux. In the picture you see, a little bottle of flux. And the reason that I am working with that, and I know Robin is like, hey, that's a lot of whiskers. Wes says, whiskers? I haven't shaved since 1995. Not those kind of whiskers. So what Robin's referring to is that tin in solders can grow whiskers. Literally, it can over time, I don't know if it's moisture or acids or whatever, but over time it could generate a whisker, and that whisker can cause an electronic short. And that failure mode was traced back on a lot of interesting, aircraft electronics failures they discovered were getting caused by whiskers, and that led to all sorts of standards for solders used in electronics that would not have that effect. But here I am messing around with this tin-based solder and this crazy flux. So let's read the label on this flux. It says, and I will read it to you, it's called Superior number 1261 aluminum soldering flux, viscous liquid. So Wes says there is a YouTube video on tin whiskers. Look it up. So I wanted to solder to aluminum. Now, if you've ever tried to solder to aluminum with normal solders, you will have pulled some of your whiskers out on top of your head. There's some tricks to it. You can go under oil, for example, and scrape through the aluminum to get rid of the oxide physically, and then do the soldering under oil so that oxygen can't get to it. Well, another way to do it is using this flux from Superior. And it allowed me to solder. Of course, I was working on an antenna project, which is why I wanted to solder to aluminum. And I have to tell you, this combination of that flux and this little solder pot using this SN100C, and that's why I have it in two forms. I have it in the bar to feed the solder pot, and I have it in the wire for the small stuff. Evil says, if that's pure tin, you should hear it cry when you bend that bar. Dude, I'm not bending this bar today, okay? Maybe another day we'll try to bend it, but not today. So with the right flux and the right solder, you can take a copper wire or other and solder it to aluminum. And that's what I got excited about. And that's what that setup was for. And it works. And it works. 6061 aluminum. I was soldering wires to it. I was so excited, I can't even explain. Josh says, oh, you will hear something cry, but not the bar. That is correct. Josh saw me take off my hand brace earlier. And it's like, yeah, if I try to bend that bar, I will cry. I'm not too proud to admit that. Okay. So, you have to pick the right flux. So getting back to the idea of a eutectic, the reason when you read a spec sheet, if there's more than one temperature specified, chances are it's not a eutectic mixture. And there's only one eutectic mixture I found in my collection, and that was the 6347, which is a with lead solder. So let's see. Finally, let's talk about heat sources. So, the solder pot right there in front of you, that's being electrically heated. A soldering iron on the electronics bench is being electrically heated. However, you could use a torch. So I have an air map gas torch in the shop, which I like to use. You could have an air propane torch. You could have a oxypropane torch. You could have an oxy map torch. You could have an oxyacetylene torch. Be careful, it's starting to get hot. Those are all valid heat sources. Your TIG torch, again, I tried TIG brazing and it was not fun. So you have to pick the appropriate heat source. Now, the whole area of silver soldering, the reason I bought the Stay Bright is I wanted a silver bearing, high strength, but low temperature solder, and that's what the Stay Bright formulation is. As you go up to high silver content, your temperature requirements go up. And when you see, Robin with the black flux and the torch and getting the carbide brazed to the steel, those temperatures are really high. Okay, but you end up with a strong connection, and it works. But that we have no problem differentiating that by calling it brazing. But really, it's got a flux, it's got two metals, it's got a heat source. It's happening at a higher temperature, but it's the same thing. So the last part I'll touch on briefly is cleaning. So after soldering comes cleaning, and everything. Robin says 56% silver is actually a lower temperature, lower than full silver soldering. Is that what you're trying to say? Yeah, StaySil 56. Here it is, right here. So this is what Robin's talking about. This is in my kit. StaySil 56 brazing filler, and that's 56% silver, 20. Well, it says 55 to 57% silver, 21 to 23% copper, 15 to 19% zinc, and 4.5 to 5% tin. Wouldn't you like to meet the guy that came up with the formulation? And its liquidus temperature is 1200 F. Okay, 652 C. And the brazing range is 12 to 1400 F, or 650 to 760 C. So it's pretty hot, but there it is. And that's StaySil 56. And there's all sorts of different formulations. I think that's the one you like, Robin, and I believe that's I have a coil of that downstairs for the same purpose. Not good for IC work. Negative, Dale. Well, actually, it would work really well for integrated circuits. Once. Indiana John says, interesting, cause copper melts at 1984. Yeah, you're not going to be using that on copper. That was, between, in Robin's case, that's between steel and carbide. So both of those things will be just kind of laughing at you. Okay, last thing to think about is cleaning. So after the soldering / brazing comes the cleaning. Now, in soldering, we have a bunch of fluxes called no-clean fluxes. And really, it's not that the flux goes away. It's that the flux isn't going to corrode anything after you're done or at the temperatures of operation. So in any of these processes, you have to ask the question, how am I going to clean this stuff when I'm done? In plumbing, it's frequently abrasively, right? I'm just going to get out my abrasive cloth and clean the joint to make it all clean. Sometimes that's not practical and you need a chemical cleanup. Sometimes isopropyl alcohol will clean up something. Sometimes, yeah, Indiana John. So, yeah, you're referring to the. So Indiana John says, "Hey, you said there was some copper in some alloy." Yeah, right here, the Odie Safe Flow, which is a plumbing copper. It says that it contains tin, copper, bismuth, and silver. Yet they claim a melting temperature of 420 to 460 F. How can that be? Copper melts at a much higher temperature. Welcome to the world of eutectics and mixtures, because it's chemistry, it's physics, and I can't explain it. So yes, you can have copper in an alloy that melts at a lower temperature than copper, and it will still melt. Okay? You want to study that? You have a whole world ahead of you. So have a cleanup plan for whatever particular process you're using. In electronics, it's isopropyl alcohol, and it works great. But that's because it's a particular flux, and we know that isopropyl is going to clean it up. Yeah, so Evil says, well, salt melts well above 0°C, but adding it to water lowers that melting point. Yeah, physical chemistry, baby. You could spend many years on it and get a bunch of letters after your name. Right, Carl? All right, I'm going to cut this short because we had too much fun. So soldering. Do it, but do it right, and do it safely, and wear eye protection, and have proper ventilation, especially when you're working with fluxes, and especially when you're working with lead. And but yeah, anytime you need to join two metals together that the metals themselves are not melting, you are either brazing or soldering. The difference of those two happens at 450 degrees C, just because we say so. It's all the same. All right. Well, this has been awesome. You guys are awesome. I know a couple of guys. Oh, wait. Dale says, so holding the lead-bearing solder in your teeth is bad. I cannot tell you how many times in my long history I saw people doing that. Yes, it is bad. Don't do it. Paul asked a good question. What size capacitors should you use with the flux? If you keep the power down below 1.21 gigawatts, you could use any capacitors. Above that, you'd have to use ceramic capacitors. Okay? Thank you, Paul. Thanks. I wanted to cover that. Art that makes art. Wes says, remember to like the video. Yeah, hey, hit the like button. If you want to subscribe, you'd be welcome. Hit the subscribe button. Our entire library is down at PFG.Live. That'll take you to the YouTube playlist. If you need something flat, head on over to PFG.Stones.com and get yourself some stones, which are PFG. So thanks for being here. We'll be over in the after party roundtable having finger sandwiches. Right now, there's freezing rain blowing around outside my window, and I'm going to have to deal with that. So wish me luck. Have a great rest of your weekend. We'll see you guys next week. And no matter what, get flat and stay flat. We'll see you next week.